Okay, question number 1. So you need to identify the pieces of apparatus that are needed to determine which salt it's more soluble. So there is a sodium salt as well as a potassium salt. So in order to determine which salt is more soluble, you need to find out the mass of the salt that can dissolve in a fixed volume of water. Okay, the mass of the salt that can dissolve in a fixed volume of water, which means that you need the electronic balance to measure the mass of the salt, as well as a fixed volume of the water, right? You need a measuring cylinder. But sometimes we need also to find out the solubility of the salt at different temperatures. This is a solubility curve for the different salts. So we need Bunsen burner to heat up the water. And of course, we'll need a thermometer as well in order for us to find out the temperature of the water. Yeah, but since there is no option that has 1, 6, 5, and 4, so we choose the best answer because we need Bunsen burner to heat up. Yeah, so we choose 156 instead of 146. Question number 5. So this is a simplified structure for asbestos. So the bonds present in asbestos, you can see that this is magnesium ion, this is O minus, is an oxygen ion. Okay, so ion, negative ion, positive ion, so this is ionic bond. And then this line means sharing of one pair of electrons, so this is covalent. So it has both covalent and ionic bonds. Okay, question number 6. So possible electronic configurations for the elements in the above molecule. So let's look at the options one by one. So for A, the white circle, electronic configuration 2.5. So 2.5 means that it is short of 3 electrons. So need to share 3 pairs of electron. But this one only share 1 pair. So cannot be. 2.6 need to share 2 pairs of electron. Only share 1 pair of electron. Cannot be. So 2.7. Yeah, 2.7 share 1 pair of electron. So it's possible. C. D, also this one is 2.8.7. Share 1 pair of electron. However, 2.8.7 means that there are 3 electron shells, and the black circle 2 electron shells. So the white circle having 3 electron shells should be bigger than the atom with 2 electron shells. So D is out because D, your 2.5, it's bigger than 2.8.7, so cannot be. So the only possible option is C. 2.7 share 1 pair of electron. Now the question is this one 2.3, right? How come 2.3 need to share 3 pairs of electron? Now, so this is actually an exception. So if you look at the periodic table, 2.3 is actually boron. Yeah, so boron, when boron form bonds with the halogens, they do not obey the octet rule, meaning that after bonding, it does not have 8 electrons in its outer shell. Okay, so this is an exception. So this happens for compounds of boron fluoride, boron chloride, etc. So boron with a halogen. So in this case, when boron forms bond or share electrons with 3 fluorine atoms, this boron atom only has 6 electrons in its outer shell. So it does not obey the octet rule. So this is an exception. It's the same case for aluminium. Yeah, aluminium, same thing. So aluminium fluoride. Now aluminium, even though it's a metal, but it forms covalent bond with fluorine, chlorine, etc. Yeah, and then when they form covalent bonds, they disobey. It disobeys the octet rule, meaning that aluminium atom, after forming bonds with 3 fluorine atoms, the aluminium atom only has 6 electrons in its outer shell. Okay, take note these 2 elements, boron and aluminium. Question number 10, this is the reaction between citric acid and sodium hydrogen carbonate. This is a chemical equation, and the question wants the maximum volume of carbon dioxide. So the volume is how much? Given off when 1.92 gram of citric acid, this is 1.92 gram, reacts with 30 cm cube, 0.5 mole per dm cube, sodium hydrogen carbonate. So 30 cm cube, 0.5 mole per dm cube. Okay, so carbon dioxide is the product. So the amount of product depends on the amount of limiting reactant. So we need to find out which one is the limiting reactant first. So the mole ratio is 1:3. So we need to find out 1.92 gram of citric acid. How many mole is it? So 1.92 divided by citric acid. The MR is 192, and that would give you 0.01. And likewise, we need to find out the number of mole of sodium hydrogen carbonate, which is the volume times the concentration. So the volume, change it to dm cube. That will be 30 divided by 1000 times 0.5, and that will give you 0.015. Okay, so this is 0.010. So from here, since the mole ratio is 1:3, so if I have 0.01 mole of citric acid, I would need 0.03 mole of sodium hydrogen carbonate, but I only have 0.015. 0.015 is less than 0.03. Therefore, your limiting reactant is sodium hydrogen carbonate. And therefore, we can find out the mole ratio. So the amount of the product depends on the amount of limiting reactant. So the mole ratio is 3:3, which is 1:1. So the number of mole of carbon dioxide would be the same as the number of mole of the limiting reactant, which is sodium hydrogen carbonate, which is 0.015, and the volume would be 0.015 times 24 dm cube. That would give you 0.36 dm cube, which is 360 cm cube. So the answer is C. Question 17. Okay, the solution X reacts with solid oil to form a gas. So a gas is given off. Now, you want to find out the suitable methods for investigating the speed of reaction. So you need to measure something. So in this case, the gas will build up in the conical flask, and you have a stopper here, so the gas cannot escape. So this will result in explosion because of the gas built up in the conical flask. Okay, the electronic balance, does it record? Does the electronic balance be able to record any decrease in mass? It won't, because the gas cannot escape from here, so there will not be any reduction in mass of the conical flask. Okay, if you compare with 2, so 1 is out, so 2, yes, the gas will escape through the cotton wool. So this conical flask, slowly the mass will decrease. Yeah. So we can actually measure the speed of reaction by measuring how fast the mass decrease in the conical flask. So 2 is in. How about 3? So 3, basically what you're measuring, what you are collecting is actually the volume of gas evolved by the reaction. Okay, so 3 can. 4 cannot, because 4, you are not collecting the gas. You are not collecting the gas evolved, because some gas will escape through the cotton wool, some gas will get collected. So 4 cannot be used to investigate the speed of the reaction. Question number 18. So reaction between sulfuric acid and excess zinc powder. So what it's trying to imply is that your sulfuric acid is a limiting reactant. So the amount of limiting reactant determines the amount of product, which in this case would be the volume of hydrogen. So the height of the curve is determined by the limiting reactant, which in this case is sulfuric acid. So we need to find out the number of mole of sulfuric acid here is 50 divided by 1000 times 1, and that will give you 0.05 mole. Okay, which change would produce curve 2? So you can see curve 2, it's taller. Okay, it is taller than curve 1, which means that the limiting reactant is more. So let's look at 1, use 80 cm cube, 1.5 mole per dm cube. So in this case is hydrochloric acid. So we need to find out how many mole of hydrochloric acid is this. And this is 80 divided by 1000 times 1.5, and that will give you 0.12 mole. Yeah, 0.12 mole, it's more than 0.05. Okay, so the limiting reactant, it's more, so it is higher. Now how about the steepness or the gradient of the graph? So you can see 2, it is less steep, 1, it is more steep. Okay, so hydrochloric acid, you should know that hydrochloric acid is a monobasic, meaning that 1 mole of hydrochloric acid produces 1 mole of hydrogen ion, whereas sulfuric acid is a di-basic. Every mole of sulfuric acid produces 2 mole of hydrogen ion. So that is the reason why curve 1 sulfuric acid, okay, it is the gradient is steeper, okay, so which means that the reaction is faster. And then for hydrochloric acid, limiting reactant, a greater number of mole, so the curve is taller. Let's look at number 2. At 10 cm cube, 1.5 mole per dm cube. So this one, you have to know the number, you have to calculate the number of mole, and this number of mole would be 10 divided by 1000 times 1.5, and that will give you 0.015. And likewise for this 50 cm cube, 1 mole per dm cube, the number of mole would be 50 divided by 1000 times 1, and that will give you 0.05. Okay, what is the total number of mole of sulfuric acid? Total number of mole of sulfuric acid is 0.015 plus 0.5, which is 0.065. And 0.065, it's more than 0.05, so it will be taller. Okay, so it will be taller. So it's possible. How about the steepness of the graph? Now this one, both are sulfuric acid. And you look at the concentration 1.5 and 1. So if you have 2 sulfuric acid solution with concentration of 1.5, and then the other one is 1, when you add up together, the concentration must be more than 1, must be in between 1 and 1.5. Okay, so which means that for number 2, right, the curve would be steeper because the concentration is higher than 1. It's in between 1 and 1.5. So the concentration is higher than 1, meaning that the gradient would be steeper. But in this case, your number 2, the gradient is less steep, so it cannot be statement number 2. Okay, how about for number 3? Add a larger mass of lumps of zinc granule. Larger mass of lumps. In this case, it's zinc powder. So if you use lumps, the speed of reaction would be slower. Okay, and then larger mass, and then the limiting reactant is the same, so the height would be the same. The height would be the same, but in this case, graph 2, the height is taller. It is taller than 1, so it cannot be. So number 3 is out. So therefore, the answer is 1. Okay, question 29. What happens when one end of both rods touch each other as shown in experiment 2? So when this happens, this is like a simple cell. Okay, it consists of 2 electrodes of 2 different metals with different reactivities. So the more reactive metal tends to lose electron to the less reactive metal. So in this case, the zinc rod will lose electron. So which means that zinc loses electron to form zinc ion. So this is what happens on the zinc electrode. Okay, it will slowly dissolve, and then a copper electrode will have a lot of electrons, and when there are a lot of electrons, it will attract the cation, and the cation in this case is the hydrogen ion. So the hydrogen ion will be attracted to the copper electrode and discharge to form hydrogen gas. So there will be hydrogen gas, there will be gas bubbles around the copper electrode. So the answer should be B. Effervescence observed around the copper rod only. Question 34. So in the analysis of oleic acid, MR is 280, it is found that 56 grams of the acid requires 0.8 grams of hydrogen gas for complete hydrogenation. So first thing you need to find is to find out how many mole of the acid is this 56 gram. So the number of mole of the acid would be 56 divided by the MR, which is 280, and that would give you 0.2 mole. And then 0.8 grams of hydrogen gas. The number of mole of hydrogen gas, that will be 0.8 divided by the MR of H2, which is 2. And that will give you 0.4 mole. So you can see the acid, the mole ratio of acid and hydrogen is 0.2 to 0.4, which is 1:2. And in the question it says 1 mole of the carbon-carbon double bond reacts with 1 mole of the hydrogen gas. So in this case, I have 2 mole of the hydrogen gas. Okay, so what it means is that there should be 2 mole of the carbon-carbon group in the acid. So the number of carbon-carbon double bonds in the molecule of oleic acid will be 2, because the acid, 1 mole of acid needs 2 mole of hydrogen gas for complete hydrogenation. Okay, 35. How many isomers can be formed from C2H3Cl3? So we can draw the structural formula. CC H okay, CH3 and then Cl Cl Cl. Okay, so this is a structural formula. How many isomers? So isomers have the same molecular formula but different structural formula. So structurally they are different. So there are 2 carbons here. Okay, so and then this carbon has all the hydrogen atoms, and then this carbon has all the chlorine atoms. So we can actually swap them around. So what if I swap this chlorine to here? Okay, actually this one is the same, because I can always turn it around, then become like this. Okay, how about this chlorine? This chlorine here, I can swap around. Maybe I will swap this chlorine with this hydrogen. Alright, so regardless of how you twist and turn the carbon atom, these 2 structures can never be the same. Okay, how about if I again I swap around this hydrogen, chlorine, hydrogen, chlorine. Yeah, so these 2 structures are actually they are the same, because this carbon, I turn it, I spin it, I rotate it, it will be the same, exactly the same as. So if I rotate this hydrogen will be here, will be at the bottom, and the chlorine will be at the top. So it will be the same as this structure. Yeah. So regardless of how you swap the atoms, you will only have 2 isomers, this and this. So there are 2 isomers for this compound. Okay, 38. So this is the odor of the pineapples using the organic compound. So this is actually an ester. Yeah, so it has a ester bond here, COO. So ester is formed from the reaction between carboxylic acid and alcohol. So which row correctly shows the pair of reactants that will react to form this compound and the name of the compound? So it's very clear here. So this is actually carboxylic acid, group COOH. Yeah, so remember when carboxylic acid reacts with alcohol, for the carboxylic acid, the CO bond is broken. Okay, the CO bond is broken. And for the alcohol, the OH bond is broken. So the H is gone. For the alcohol, the H is gone. For the carboxylic acid, the OH is gone. So they form H2O. So this is the carboxylic acid. So the carboxylic acid should have 2 carbon atoms. So it is ethanoic acid. 2 carbon atom, ethanoic acid, CH3COOH. Okay, and then for the alcohol would have 1, 2, 3, 4 carbon atoms. That means it is butanol. So 4 carbon atoms. Okay, this one is 4 carbon atoms, but this is not an alcohol. This is a carboxylic acid. So likewise, this is an alcohol, this is an alcohol. So we want carboxylic acid. So the carboxylic acid should have 2 carbon atoms. The alcohol should have 4 carbon atoms. And then the name of the compound, remember the name of the compound is always start with the alcohol first. So if the alcohol is butanol, it will be butyl. And then the second part of the name of the ester comes from the carboxylic acid. So if the carboxylic acid has 2 carbon atoms, there will be ethanoate. Instead of ethanoic acid, it is ethanoate. So it's butyl ethanoate. Question 40. Okay, polyacrylamide is used to manufacture soft contact lenses, part of the polymer. Okay, the structure is shown here. So from this structure, it is actually, you can identify the repeat unit. The repeat unit is quite clear that this is one repeat unit. Okay, this is another repeat unit. This is another repeat unit. So you can see all the repeat units, they're all the same, which means that this polymer is made from one type of monomer. Yeah, so and if the polymer is made from one type of monomer, and that is an addition polymer. So C must be, statement number 3 must be correct. It is an addition polymer. It contains amide linkages. What is amide linkage? Amide linkage is CONH. Okay, C double bond O, single bond N, single bond H. So this is CONH. Is there a CONH here? Don't have. It's CONH2, which is different. So statement 1 is wrong. The molecular formula of its monomer is C3H5NO. Now, actually you can, so this is actually the repeat unit, right? So this is actually the monomer. Yeah. So what is the molecular formula for the monomer? How many carbons? 3 carbon. How many hydrogen? 3, 4, 5. 5 hydrogen. How many nitrogen? 1. How many oxygen? 1. So it is C3H5NO. So just for practice purpose, if the question asks you to draw the structural formula of the monomer, that would be the structural formula of this. You just need to add in the carbon-carbon double bond. So if you draw it out, CH2, CH, right? CH. So the carbon-carbon double bond must be here. In order for this carbon to have 4 bonds, and then this carbon to have 4 bonds. Right now it's 3, right? Because there is still some extension here. So this is actually the structural formula of the monomer for this polymer. So it's exactly the same as this, except that you have to show the carbon-carbon double bond here.